Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to describe the three different methods of heat transfer. So before we start talking about heat transfer, it's very important to understand what heat is. So heat is a transfer of energy due to a difference in temperature. And if you're not familiar with that, I've got plenty of videos here that talks about that. And heat is transferred one of three ways, and I've already written down here. Heat is transferred via conduction, or convection, or radiation. And I'm going to take these one at a time and talk conceptually here about these three things, starting with conduction. So first of all, I want you to pay attention to this picture here, and here's young Timmy that I use in lots of my videos here for various things. And imagine that Timmy is holding on to a spring which has a mass attached to it, and then another spring, and then another mass, and then another spring, and so forth, all the way, down some sort of line. Now, don't worry about, why is this not sagging or gravity or other effects. Just imagine for the moment that this line of masses is nice and straight. And imagine Timmy grabs onto this mass, and he starts moving it back and forth like this. Left, right, left, right, left, right. So what's going to happen? This mass will start moving left or right. It'll start kind of going back and forth, back and forth, back and forth. Now, eventually, this mass will start moving back and forth, and this effect will kind of propagate down this line here. When Timmy first pulls on this mass, these guys way over here are not going to be moving hardly at all. So as Timmy kind of moves his hand back and forth, this guy will start vibrating back and forth, and that'll cause this guy, and that'll cause this guy, and then this guy, and this guy. And if Timmy keeps doing this long enough, eventually all of these masses will be vibrating back and forth at the same amplitude, if he does this long enough time. Now, if they're moving back and forth and they have the same amplitude, that means that their average speeds are about the same here, 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 and so forth. So what we're seeing occur is we're seeing kinetic energy basically move from left to right. When Timmy first grabs onto this, none of these guys are moving very fast. Timmy grabs on, starts moving this further back and forth, back and forth, back and forth. These guys will eventually start moving back and forth, back and forth, back and forth. So the kinetic energy, the average kinetic energy of this object will increase. Now remember that temperature is a measure of molecular kinetic energy. So what's happening, if I were to describe this in terms of temperature, is the temperature of the system is starting to increase as we move from left to right. So we have an energy transfer in this direction. Now, molecules behave somewhat similarly. So if I look at this picture now, here's Timmy standing next to a campfire, and imagine he's holding a metal fire poker here. In this region right here, this metal is going to get really hot, and that means that the molecules are going to be moving back and forth quite a bit faster, because remember, temperature is a measure of molecular kinetic energy. And these molecules behave a little bit like this mass spring system here. These molecules will bump into their neighbors and make them move a little bit faster, and they'll bump into their neighbors and make them move a little bit faster. So as long as Timmy keeps this end in the fire, the average molecular speeds as we move up this bar will start to increase. So when he first puts this poker in the fire, the temperature right here is relatively low, and that means the average molecular speeds are very small. But over time, because of the constant energy that's being put into the system over on this right-hand side here, the average kinetic energy of all the molecules will increase. This effect will move right on up the bar, just like over here in this example where the effects of these masses moving back and forth, that effect would kind of move to the right. So that's what conduction is. It's energy transfer due to the molecular interactions here, where in this bar that would be occurring kind of in this direction, meaning that the molecules here are hot almost instantly due to the fire, and that effect will kind of propagate up the bar. So conduction is heat transfer due to molecular interactions. Very important thing to realize, you have to have molecules here to interact for conduction to occur. All right, convection. So convection is heat transfer due to mass flow. So what's going to happen over here, getting back to my fire, the air above this fire will get hot. And when that air gets hot, it'll start rising. So that air is going to move in this direction. And what's going to happen is cooler air will come in and take its place. And everybody that's probably sat by a campfire has noticed this. So now we have heat being taken away from the fire due to the movement of the air. So that's an example of convection. Another example would be if you put your car out of the window as you're driving down the road, you'll notice that your hand cools off very quickly. So that would be an example of convection. So convection is heat transfer due to mass flow. Right. Radiation. So heat transfer due to radiation is because of what we call light, or what are called electromagnetic waves. I'm not going to get too deep into this video. This video is meant to be just a conceptual video here, but young Timmy, if he's standing close to the fire, that glow that you feel on your face or on your hands, that's from electromagnetic radiation coming from the fire. A very important difference between electromagnetic radiation and convection and conduction is this: there is no mass needed for this guy, or no medium. Radiation, you can have heat transfer right across empty space. An example of that, our sun transmits energy to the earth in the form of what we would call heat, in the form of electromagnetic radiation, and there's no matter. I mean, there's a little matter in there, but you do not need matter in between the sun and the earth for this to take place. Radiation can occur right across a complete vacuum. That's not true for conduction and convection. Again, convection is heat transfer due to mass flow. No mass flow, no convection. And conduction is heat transfer due to these molecular interactions here. The molecules here in this bar are moving very fast when the temperature is high, and they kind of bump into their neighbors, make them move faster, and they bump into their neighbors, make them move faster, and this effect moves right up the bar. So without these molecules here, you can't have any more conduction. So big difference between radiation and the first two. Radiation requires no medium. So again, this is just meant to be an introductory video into the three modes of heat transfer. I think I'm going to leave that off right there. So I hope that this successfully introduced you to these concepts. Have a great day.